Hi guys, welcome back to Data Every Day. Today we'll be looking at a data set of space missions since 1957 and using a series of attributes to try to predict whether or not a mission will be successful. So each example here is a mission, and at the end we have our label column, which will give us a success or failure. So let's get started. As you can see, I've laid out the steps that we're going to take. I'm going to start by just importing our normal libraries, these classic 3 libraries, and importing our data using the pandas.readcsv function. And we're going to get the file path to our CSV file over here. Just copy that and paste it right in. And then, whoops, check it out. Okay, so I'm just going to put, okay. Alright, so as we can see, we have 2 columns here that are unnecessary because they're just duplicate index columns. We already have an index column, so we're just going to go ahead and drop that. So right here actually, data.drop, and since I don't want to type that out, I can just get the index by doing data.columns indexed at 0, and I gotta put this in the list here. We're also going to do data.columns indexed at 1. And let's take a look at any other features that we might not need. So what's going to give us useful information about the success of our mission? Well, what's something we see definitely won't? I think detail probably is not going to give us useful information. It's just sort of a cool sounding names. There's not really any data here that's going to give away the success of the mission. Except maybe if it says Sputnik, I don't know, it's a pretty famous rocket model, I think. I don't know. I think in overall we should probably just drop this. So we're going to get rid of detail. And then in addition, it would be very difficult to actually work with this data. We'd have to figure out, okay, do we want to just take certain words out of it? Do we want to one-hot encode the entire thing, which would give us a tremendous number of features. I'm assuming it's unique for each of the 4,000 examples. So we'll get rid of that, and then let's look at location. Now, location might give us some useful information, but the company name is probably going to give us even more useful information. I mean, what I mean by that is a lot of what the location is conveying is actually conveyed better or more strongly with the company name. For example, you see SpaceX obviously has both in USA here, whereas Roscosmos is operating from Kazakhstan. So it's tricky, you know. Should we try to encode this, or should we just drop it? And I think we'll probably just drop it, because we should be able to do a good amount with what's left after we drop those. So let's drop all of these, and we have to specify which axis it is. So the column axis is 1, so we'll drop it from axis 1, and we'll specify that we're doing it in place. So now we'll take another look at data down here, and you can see this is a much nicer, easier to work with data set that still gives us useful information for predicting the success of a mission. You know, in terms of as far as data goes, this really is probably not going to be very predictive, because you know, how much can you tell about whether a mission will fail based on 4 features? You know, even if we used everything, 6 features, it's not. So you know, all we can really hope for here is let's get slightly better prediction accuracy than would a random guess. If we can do that, I'd say this is a job well done. So, and I notice on Kaggle here, nobody has even attempted this. Everyone is just seems to be doing exploratory data analysis and data visualization. So let's give it a try. Let's see. Alright, so we're pre-processing this data now, and we're going to start by looking for missing values. And before we get started, I just wanted to point out that when I was working with this dataset earlier, I noticed Rocket actually has a trailing, leading white space character at the beginning, which is just making it sort of annoying to deal with. So why don't we go ahead and just rewrite that. So the data.columns equals the same list as before, except we'll just get rid of that little white space. Okay. Alright, now we're working with missing values. So we can get the it's a matrix or a data frame that shows all the missing values, where we only have a true if there's missing values in that spot. For example, this is a missing value, this is a missing value. Anything with true is a missing value. And we can find the number of missing values in each column by summing across the rows, calling the sum function. And it looks like Rocket has 3,360 missing values, and no other column has any. So let's take a look at Rocket. Let's see what's going on there. So let's find the unique values in there. And you can see this is actually a numerical column, but it has been entered as strings. Each one of these is actually a string instead of a number. And you can see there's commas in there. So we're not going to be able to do an explicit cast to float, but we can work around that by applying a lambda function to remove the comma. And simple way to do that is we'll get our Rocket column dot apply, and we'll specify the lambda function that takes in some value x, which will be one of these, and we're just going to say we're going to replace it with we're going to call x a string replace function. It's going to replace a comma with nothing, with the empty string. Right, so this is saying we have some x, which is one of these. Let's say where's one? 5,000.0. It takes x as 5,000 as x, and we replace it with x.replace, replacing a comma with empty. So what we'll just get back is the same thing, just with no comma. And that will happen for each element in the column. So once that is done, we can then try to cast it to a float. And we'll use numpy's float32. Alright. And it looks like very interesting. Float object has no attribute replace. So let's look at the data types. Well, it says that Rocket is an object column, but let's look at each one of Rocket. So actually, for value in data Rocket, print type of value. Oh, sorry. Okay, and very strangely, okay, this is supposedly a float. Weird. It's a mixture of strings and floats. So, based on that, what we're going to have to do is first cast it to a string, then replace the comma with an empty string, and then turn it back into a float. So right here, we'll do as type string. So what we're doing, we're taking the column, we're turning it to strings, so that all are strings, which is easy to do. Then we replace any commas in it, and then we will cast it back into a float. And that should give us what we need. So if we just look at what that looks like, looks good, everything's good. Now we have NANs where they should be, and we'll just save the column like that. Okay. So now we can impute the missing values. Because they're floats, what we could do is just change every NAN to the mean of the values that are there. So easy way to do that, data rocket.fillNA means fill missing values with a certain value, and the value we'll give it is the mean of that column. So all the missing values will take on the same value, which is just the mean. This is a convenient way to get rid of missing values in numerical columns without dropping the rows or losing information or messing with the variance too much. So this should be good. We just have to save that in there. Now let's just take another look at data, and you can see we don't see any missing values here. Let's just check again, and now we see there are no missing values at all. Right, before we had these many, now we have nothing. Okay, so now we can move on to encoding. Let's take another look at our data, and we can see we have to do a fair amount of encoding here, because rocket is actually our only numerical column. Right, so company name is going to be one hot encoded because there is no order between the unique values. Why don't we go ahead and just look at the uniques? So data, so company name, that unique. You can see there's a whole lot of unique values here, but no, they're not in order. They're not ordered unique values. They're called what you call nominal. It's a nominal categorical feature because, for example, SpaceX doesn't come before CASC or vice versa. So, what can we do? We can just go ahead and one-hot this, but I'd like to save one-hot till the end because it adds a whole lot more columns onto our data, which is just sort of cluttering. So let's save that till the end so we can work with a smaller data set for now. So what about datum? So this is a date, and let's say we want to get the year and the month, because those are probably those could be indicative of the success of a mission. Because the year, you know, an older mission probably has a higher chance of failure because the technology wasn't as good, and the month could have an effect because the weather might play into the effect of the mission. So why don't we use those as two new features that are encoded? They're stored inside this one datum column. So there's a few ways we could go about doing this, but I think we can use regular expressions to capture the year and capture the month. So for regular expressions, we're going to have to import RE. That's Python's regular expression library. And we will start with the year, I think. So I'm going to write a function that's going to it's going to capture this and turn it into an integer. Alright, so we'll call it get year from date. And it's going to take in some date. It's going to give us back a year. And so the regular expression that we want here, we're actually going to use two regular expressions. And I'll just go to this very wonderful, beautiful website. If you don't know about it, regex101.com. You can paste in a string and then experiment with regular expressions to see how they interact, right? So you get the idea. All right, so we want a regular expression that's going to give us just this, and we can use multiple. Okay, and I was experimenting around, and I found I couldn't find a great answer on how to do it with one regular expression, but I was able to do it with two. So the first one is going to be this. So this is saying, all right, this guy means end of the line, and it tells you everything right here. It gives you a whole breakdown of what this is doing. But the $ means start at the end of the line, right? And from the end of the line, look at this thing. So this is a set, and the little caret inside the set means let's match anything that isn't in the set. So comma is what we don't want to match. So it's saying match anything that isn't in this set, meaning anything that isn't a comma, any number of times. That's what that means, until we hit the end of the line. And because we put the end of the line here, if we took that off, you could see it does everything but a comma. But if we put the end of the line, what's it called? Assertion, maybe. If we put that here, you can see it only takes the part that's connected to end of the line, and it doesn't worry about this part, which is good, because now let's just store this in our notebook for later use. And we're just going to, we're going to cut it down to what that is. So now we're dealing with this string. And now it's quite simple to get 2020 out of it. All we have to do is we say start at the beginning of the line, find some white space, that's what \s means, and then match anything that isn't white space, one or more times. And that's that. See? Now we'll be left with 2020. And we could do this one. I guess that just for consistency we'll use that one. And so these are our two regular expressions. If we apply these to a date, we should be able to get back the year. So let us say year is going to be regular expressions.search. So this search is a string for a pattern, and we specify the pattern with a raw string here, right here. So that's the pattern we're looking for, and then we're going to search it. We're going to search the date for that pattern, and it will return a series of groups that it finds. So we want to get the first group, which is it's only going to match one thing, so we just do group 0, and we're going to then again apply a second regular expression, which will search year this time, right? Because we updated year. Now we're going to search year for this pattern, and we'll get group 0 again. That will return the string. This just returns the string. This thing returns some match object, and this just gets the string that it found. Okay. And now we will return numpy.int16. We use a 16-bit integer here, year.strip. Although I don't think we need to strip it. Let's not. Because the reason I did strip is strip will take off any leading or trailing white space. And as you can see, there will be a leading white space here. So I think this should work though. I think we can still cast. Let me just see. np.int16 of space 2020. So we have this string. Yeah, that works. Okay, so we don't have to strip it. That's good. All right, and here's our function that will take a date and give us the year. Now we'll do the same thing for the month. So if we're gonna, here, let me just get this again. Let's say we want the month from here. To get the month, well, we can start by saying, okay, start at the beginning of the line, and then match anything that isn't a number. Because the number comes right after the month, we can say that. So anything that isn't 0 through 9. And then it's only matching one time, so we want to match as many times as possible until we hit a number. Right? So that will be our first regular expression. We'll just pop that in here. I'll make a new function, get month from date. Takes in some date, give us back the month. Then we'll put that in there. And now we'll just chop it down to this. And now we need a regular expression to just get August. And it's already if we have white space on either side because we can just strip it. But so we can say, alright, find some white space, and then everything that follows. Right? And we can just put end of line there to make it assured. And that will just give us August. So that's fantastic. This will be our final regular expression to get the date. And so we'll say month equals regular expression dot search. So the pattern we're searching for is this, the first one. And the string we're searching will be date. And then we just want to get the string back with group sub 0. We'll do the same thing again for the second expression. Month equals read dot search. This time we use this guy. Date group 0. And now when we return this, we're not going to cast it to an int, right? Because we want a string. But we have to strip it from any white space. Because if you saw, this will have one white space at the beginning, one white space at the end. So if you didn't know, you can say hello world, and we'll just put a space on either side. Dot strip will give us back the same string, but with all the white space taken from each end off. It's a very useful feature. So we're going to return month dot strip. Alright, that should do it. So let's try making two new columns, one called month, one called year, and just removing the original column. So let's say, alright, data sub month, I'll do year first, is going to be the datum column, which was our original column, right? Dot apply, and the function will apply to every element is going to be our get year from date. Then we'll do the same thing, whoops, this time for month, and we'll apply get month from date. Then lastly, we'll just drop the original datum column, which we no longer need. Date is not defined. Where's date? Get year from date. Oh, this should be date, not data. Okay. There we go. Alright, now let's look at data again. And fantastic. Oh, looks like month didn't work. Why didn't month work? Well, it looks like it stripped the interesting. Let's run a single date through month. So get month from date. Oh, string. And it looks like it stripped off Friday, but nothing else. And let's see, if we just apply the second one, you can see the second one's working, but the first one isn't. So let's see, why is that? If we try like this, it should give us that, and the second one would just give us August. So what is the problem? Let's see, I did this before and it worked. Here, I'll just copy and paste this regular expression that I had in my other one, and it's exactly the same. Very interesting. Aha. Why don't I try this? I just want to see, because I did this before, and here's the one that I made, which looks identical. Oh, I see. This shouldn't be date, this should be month. This should be month. Right, because we have to modify month, not date. See? We modify date once, then we modify month. Okay. Sorry about that. Let's we have to actually rerun everything now, because I've already done it in place. So one of the problems with dropping in place, we now have to rerun our whole notebook instead of making copies. Something I'm still not great at, because you got to come up with all these different names for the copies of the data over and over again. But for now, we can reset the notebook, and then when it loads up, when we get a new draft session, we can just hit run before, and that will run everything before the selected cell. It should be any second. Alright, so there we go. Now I'll try running this one. We'll look at the data, and there we go. Okay, now we have a proper value for month and a proper value for year. And we don't have the datum column anymore, but we've actually added a new column. So what if now we worry about these guys, status of rocket and status of mission? So what's good about there's something in sklearn called the label encoder that is really good for let me just import it. It's really good for encoding your label column, because it gives everything in the label column a unique value, and it's very easy to use. So we'll just do that. We'll make a new encoder, call it label encoder, and we're just going to transform this guy, which is our status, into labels. Now it should be binary. This should be a binary classification. So let's check this, because if we look at this, right, there's actually some other values here. 106 other values that are not success and failure. So let's just take a look at that. We'll do data sub status mission dot unique. And it looks like we have these guys, which are also failures, right? So it wouldn't hurt to just make call these failures, and so we'll only have two values, success or failure. So very easy. It's very easy to do that. All we have to do is apply a little lambda function to it. We should say, take that column, and we'll just apply a lambda function. Takes in some x, which will be one of these, right? One of these, and we'll return x if we already have success, and otherwise we'll return failure. So x will stay the same if x is success, and otherwise it will become failure. So that should be good, and all we have to do is update the column. Like that. Now if we take a look at the unique values, we only have 2. That's fantastic. Okay, so now we can label encode it properly. So we have this encoder object, and all we have to do to encode it is say data status mission will be equal to encoder.fit transform. This will fit the data to the encoder, fit the encoder to the data rather, and then it will transform the data and return the transformed version. So the data we're transforming here is status mission, and that should do it. So let's run it, take one more look at our data, and you can see now we have a 1 and a 0 here. Okay, so now there's 2 more columns. Well, 3 if you count the month, right? We'll save company name for last, right? But we're going to, you notice these guys, especially the month, there is some order to them. There's a sense of progression through the months. Because some are hotter than colders, some are hotter, some are colder. So we want to label them similarly to how we did here, but we want in order. So this is what's called an ordinal feature, which is the other type of categorical feature other than nominal. So I'm going to write a function, and the goal of this function is we're going to, given some data and a column of that data, and an ordering of the values in that column, perform ordinal encoding on the column and return the result. So we're going to create this function, ordinal encode, that takes some data, a column, and an ordering. And we will return the data in that column, so we'll return the column itself with this lambda function applied, which will take in some x and return the index of that x in the ordering that we specified. Dot index. So for example, we're going to use it on month, right? So let's specify a month ordering. And we're just going to write out January, February, right? Let me just copy and paste it for sake of time. Like this, right? So this is our ordering. And if we index, if we say, okay, for example, August, if we get this ordering dot index August, it will give us 0, 1, 2, 3, 4, 5, 6, 7. And so August will become 7. September will become 8, October will become 9, and so on. Which is good, because there's an order there. The model might be able to pick up that missions with very low or high values will have worse results than missions with medium values. Because maybe, I'm not saying there is, but maybe there's a correlation between warm weather and high success. So let's ordinal encode month, and then we also want to do it for, what is it? This guy, status rocket. So this one is not so much important which order we do it in, but we'll do it just as an exercise. Status rocket dot unique. What? Oh. And you can see there's a status active and a status retired. So we'll just specify the ordering there. So we'll say status ordering. It's going to be status retired, which will be 0, and status active, which will be 1. And so if we index this at 0, we'll get, for this we'll get 0, for this we'll get 1. Now we have our orderings, and we're ready to encode. So let's use this function to just take a look at what it looks like first. The month column and the month ordering as our ordering list. Oh, what? And there it is. You can see the first 3 are 7, the next 2 are 6, and sure enough, first 3 are August, the next 2 are July, which is 7 and 6, and the last one we have December, November, October, which comes out to be 11, 10, 9, which is correct. 11, 10, 9. Alright, so we can do the same thing. First of all, we're just going to set month to now be equal to that. And then we're going to do the same thing for, what's it? Rocket. No. Is that what it is? Status rocket. That's what it's called. just do the same thing here. This is status rocket. And run that. Oh, it's not in the list. Did I misspell? What? No. Hey. What's going on here? Oh, I passed in month ordering. Sorry. Status ordering. Okay. 7 is not in the list. What's going on here? This is a problem with month. But we just showed that month works. Explain yourself. What is this? Didn't we just show? What is going on? Oh, right. It's because we already encoded it. Because another problem with doing it in place, we can only run it once. Okay, so let's just comment that out for now. Then we run this, then we can uncomment it. Okay, now we go with the data again, and you can see most of these are in numerical form now. We just have to deal with company name. So now is when we'll do the one-hot encoding that we've been putting off, which we'll just make a function to do. I'm just going to write this function, and I'll briefly explain it. I've used this a lot in previous videos. Basically, we create a dummies data frame, which is just using pandas.getDummies, and for the specific column that we're talking about, and data is going to be a concatenation of data and dummies. Okay, along the column axis. And then we drop the original column. So basically, dummies, I'll just show you what the dummies look like. Dummies matrix, and instead of column, let's just do month. No, let's do company name. Looks like this. It takes every unique value from company name, gives it its own column, and gives a 1 in that column if the corresponding value for the example is that column name. You see what I mean? Space X is 1, so there's a 1 here, and a 0 everywhere else. ULA has a 1. You get the idea, right? Look up in the documentation if you want some further information. So we're getting that dummies matrix, and we're going to concatenate it onto the end of data. And then we're going to drop the original column that the dummies matrix was generated from. And then we'll just return that data. Run that. Now we want to one-hot encode company name. So we'll say data equals one-hot encode data and company name. Take a look at data one last time. Now everything is in numerical form, and we have all these one-hot columns at the end. So we're ready to scale. After a long encoding session, we can now scale our data. So first we'll specify our y and x. Y is going to be the status mission column, and x is going to be everything except it. So we're just dropping it off. Okay, then we get ready to scale, so we'll import the scaler up here. I'll just import the min-max scaler. Alright, where is it? Okay. And then we say scalar, so the new scalar object will be our min-max scalar. And x is going to be a scalar dot fit transform x. So again, here we'll fit the scalar to the data, and we'll transform the data, and we'll store it back into x. So min-max scalar just looks what's the max of each column, what's the min of each column, and then it squishes it down so that the max becomes 1 and the min becomes 0. So all the values after this will take on ranges of 0 to 1. So this actually returns a NumPy array, so let's just turn it back into a data frame so it's nicer to look at. And say that the columns will be the old columns, so we want to keep those column names. So now we'll look at X, and it looks like this. So everything takes on same value, right? 2020 is 1 because it was the maximum year. And looks like we are ready to train, because this looks like we can just feed it right in. So let's go ahead and train. Alright, we're going to need we're going to need one function, which is the train test split function, which makes our lives very easy. And then we will import TensorFlow. We'll do this with the neural network. I am a huge fan of TensorFlow. I think it's such a nice framework. All right. Okay, so let's split our data. X train, X test, Y train, Y test is train test split. X, Y, train size of 70%. Just do that, and then we'll get our TensorFlow model set up. So inputs will be our first layer, and this will just be a TensorFlow.keras.input layer, and we'll specify the shape of our input, which is just going to be all 60 columns in our X. So it's going to be a 60 element vector, 60 dimensional vector. And then our next column will be a dense layer with 16 nodes, 16 activations, and activation function will be ReLU. And you will feed in the inputs. Our next one will just be the same, except we'll feed in X. And our final one, is a classic architecture, will be a dense layer with only one output and a sigmoid activation. Since this is binary classification, the one output will be, it'll just be the basically if it's over 0.5 it'll guess positive, and if it's under 0.5 it'll guess negative. So it just rounds up to, or down to the nearest integer. The model will be tf.keras.model with our inputs as specified and our outputs as specified. Then we will compile our model with our optimizer will be Atom. Our loss function will be binary cross entropy. And the metrics here, well, that's an important question. What should the metrics be? Well, let's take a look before we specify that. How many of our examples are positive and how many are negative? So y looks like this, right? 1s and 0s. If we take the sum of y, we'll get the total number of 1s. And if we divide that by the length of y, we'll get the percentage of 1s in our data. And you can see 90% of them are 1s. So we have skewed classes. And when we have skewed classes, our normal accuracy metric won't do it. So we can use the area under the curve metric, which is the area under the receiver operating characteristic curve. And it's a great way of understanding your model's performance with classification problems when the classes are skewed. It combines the true positive rate and the false positive rate, false negative rate. Let me look this up actually. I just want to see which two curves it is. Yeah, it combines the true positive rate and the false positive rate given by these equations. And basically the area under the curve allows us to have an understanding of how the model does at all threshold levels. So remember I said if it's past 0.5 we'll classify as positive, if it's under 0.5 we'll classify as negative. Well, we could also have that threshold set to 0.7. If it's past 0.7 we'll classify as positive. If it's under 0.7 we'll classify as negative. The area under the curve metric takes into account all those possible values of classification threshold. So that's why it's great. It's even better than F1 score, which is what I was using previously. Okay, so we'll call it AUC, and then after we compile it, we'll fit it. So we'll specify a batch size, which will be 32, and a number of epochs will be, we'll say, let's do it with 30 epochs, and we will come back to it after. History will be our model history from the fit, and we'll fit it on X-train and Y-train. And we'll give it a validation split of 0.2, 20%, and a batch size as specified, and epochs as specified. Alright, let's run that, and while that's training, oh what? I must not put layers. I do that all the time. Oh. What is this? Metrics, not metric. Okay, now while that's training, let's plot the data. So, set our figure size. Oh, and it's already done. That was very fast. So our fig size should be 14 by 10. It's a good size for this. And we're going to specify an epochs range. So this will just make it easier to type in. Just going to be the range of all the epochs. So starting from 1 and going to epochs plus 1. Since a range will give us 0 and not including the last one, we'll just shift it over 1 to get the proper number of epochs. Then our train loss will be the history dot sub loss, and then our validation loss, val loss, is going to be history sub val loss. And you can see loss is just, this is a list of all these different losses. Val loss is a list of all these different losses, and we can use these to plot them against the epochs range. So plot epochs range on the x-axis and train loss on the y-axis. Give the label, this is going to be our training loss. And we do the same thing here, but this will be validation loss. And instead of train loss, we'll plot on the y-axis, we'll do val loss. Alright, and we'll set the x and y labels. X label should be epoch. Y label should be loss. And we'll give it a legend, so we can see. And that will be upper right. Plot.show. Alright, and we can see, you know what, let's train it for a little longer. Let's do it for 50 epochs. No, let's do 100. It went so fast. Let's just do it again. This will just give us a better looking curve because we don't have very many data points here. And then once that's done, we're going to want to find the argmin of the validation curve, or val loss. And what this will do is basically we'll see when does our model start overfitting, because the training loss will always go down. It will just get better and better at memorizing our data, but the validation loss will eventually start to go back up. And when it starts going back up, that's showing us our model is overfitting. Because given a long enough period of time, any model will start to overfit. At least a neural network. Okay, so let's we ran it, right? Okay, let's check this now. Now this is more like it. You can really see that validation loss is starting to go back up, right? So we're going to find at which point is the minimum on it, at which point is it lowest. So run that, and it's epoch 35. So we can set the number of epochs to 35, just train it again, and this should give us some better results. We plot it, and you can see now it's at an all-time low, more or less. And now we'll just give one final evaluation of our model on the test set. And we end up with a area under the curve of 0.7, which is pretty good, because 0.5 means that it's basically just randomly guessing, right? There's no level of success. 0.7 is not great, but it's quite good, because considering the data set, right? This weird data set that's trying to predict the mission success, the fact that we got 0.7 is actually pretty impressive. So I think that sums it up for today's video. If you enjoyed, make sure to subscribe and hit the bell, and leave any comments with any suggestions you might have for the channel or for me. I really enjoy making these videos. I hope you do too. Thanks so much. I'll see you guys tomorrow. Have a great day.